What is a Gaussian model and what is it used for? Well, a Gaussian model is also called a bell curve. So you've seen bell curves before. They have some large concentration of data in the center and very little data out on the edge. This happens most often when you have a bunch of variables contributing to a single output, um, uh, random variables, because if you have a bunch of genes that all affect the height of, of the population, well, everyone will typically have some genes that make them taller, some genes that make them shorter. Um, I'm getting some of the biology a little hand wavy here, but between all of the genes, most people end up in this range because you typically will have some of the things that will make you taller, some of the things that will make you shorter, but there are some people who will randomly end up in the tall end, some people who randomly end up in the short end. This is what your curve looks like in terms of an equation. A stands for amplitude. Now it's just a coincidence that it has a useful letter name. We're just using A, B, and C as our parameters. B is our horizontal shift. And that should be familiar from moving it right, doing something inside, adding, subtracting, or subtracting inside moves things right. And then C, dividing inside is horizontal expansion. Hopefully you remember E is approximately 2.718. That's Euler's number. And what do these look like on the graph? Well, amplitude represents this. So this is what A is. It's how far off off your asymptote. Your asymptote will always be y equals 0. How far off that is your maximum point? So you have a maximum, and its y coordinate is going to be A because it's A off the asymptote. The B represents the horizontal shift. So if you didn't have a B value, then it'd be at 0. This is the horizontal shift right. So that's B comma A is the coordinate of the maximum. And then C is the horizontal expansion. It's not easy to draw a particular arrow that will show the C value, but this distance is affected by C. So it will get, as C gets bigger, this will get wider, and as C gets smaller, it will shrink. So now let's look at some of the properties of this graph, things that I might ask you about. What is the domain? Well, if you look at this curve, you can put any number into this curve. It's defined at every x coordinate, so all real numbers. But the range only goes from the maximum down to the asymptote. So it's between 0, and it goes all the way up to the maximum value. If you look back here, the maximum value is based on the y coordinate, so that's from 0 all the way up to A. Your asymptote is going to be consistently, that's supposed to be a y equals 0. Your horizontal shift is B, and your maximum value is B comma A. You could call this a vertex. People typically don't call it a vertex. If they just are looking for what's the maximum output, usually they're looking for just A if they're not looking for a coordinate pair. This is applied to statistics in a particular formula. You don't have to memorize this formula. You probably will be memorizing this formula if you're in statistics class. But this has to do with when you have some sort of population distribution, it's based on the standard deviation. Has to do with your amplitude and your compression, and then your your horizontal shift is based on the average. So you move right to the average so that the curve is based at the average, and then the standard deviation determines how wide and tall your curve is. So if your standard deviation is very small, then it's going to be something like that. And if your standard deviation is very large, then you're going to have a very wide bell curve. You don't have to memorize this formula, but this is one of the things that the Gaussian distribution is used for. Based on the graph at the right, what is the average height of US women? Well, we can say that in a Gaussian, typically what happens is the center of the curve is the maximum is where you have the average, and then the maximum value is the frequency of that average. So because the x-coordinate is between 5 feet 4 inches and 5 feet 6 inches, this implies that it's about 5 feet and 5 inches is the average height of US women. The lifespan of an insect population is modeled by this equation, where x is the lifespan in days and px is the probability. What is the typical lifespan of this insect population? Well, typical lifespan. So what do these different numbers represent? This represents the probability of the typical one, but that's not what it's saying. We don't want to know how likely the typical one is. We want to know what is the typical one. 3.272 has to do with the horizontal shift, but this is the average. So that is our horizontal shift. If we were to graph this point over here, this maximum value would be 5.413, comma 0.312. And so what's the typical value? Just like in the previous problem, it's going to be our x-coordinate, 5.413, and the unit was days. Now, if we wanted to ask a question that had to do with the y-coordinate, we'd say, how likely is what is the probability of having that lifespan? That's Gaussian models.